Here we summarize the procedure for finding eigenvalues and eigenvectors of n by n matrices. So we want to let A be an n by n square matrix. Our first step is to compute the characteristic polynomial of matrix A. So we need to find the determinant of matrix A minus lambda times the n by n matrix A. Secondly, we want to find the eigenvalues of matrix A by solving the characteristic equation for lambda. So in other words, we need to solve the equation defined by the determinant of matrix A minus lambda times the n by n identity matrix equals 0. Now, a quick note here. Depending on the degree of the polynomial, this can be a little tricky. So we want to keep in mind that in these trickier cases, we can use the factor theorem to help us find lambda. Step 3. For each of the eigenvalues lambda, we now need to find the null space of the matrix defined by A minus lambda times the n by n identity. And we need a little bit more room here to finish our last few steps. One final note on step 3. We want to note that this is the eigenspace E sub lambda, the non-zero vectors of which are the eigenvectors of matrix A corresponding to lambda. And last but not least, step 4, we need to find a basis for each eigenspace. So this summarizes the general procedure that we will now be following when finding eigenvalues and eigenvectors of n by n matrices.